Okay, what's up guys? This is take 2. My first attempt, my phone died. I am hanging my phone from 550 paracord right now. Seems to be working alright as long as it'll stop swaying here in a moment. And it will stay in focus. Okay. So, got a 3 series 2100 milliamp hour 20C LiPo pack. Fully charged, ready to go. This is the test component for this evening. If it will focus. Close enough. 0.4 amps at 12 volts per motor. So this is only 0.8 amps. It's nothing to be crazy about. This is a fully breadboarded, fully functional pulse width module. This has the 555 timer with a 30-34 N-channel MOSFET and a 100K potentiometer all in here. I'm going to walk you through the jumpers here real quick. We're going to pull a couple of these out of the way so you can see it. And we'll explain basically how it's connected. I'm not going to go into detail about how it works. If you want to know how it works, you can look it up online. It's not that complicated, really. Okay, so you got the 555 timer with your little notch that denotes the top and pin 1. So, I have created a positive and negative rail across the breadboard on lines 1 and 6 by using a small jumper here and here. I have pin 1 connected to ground and pin 4 connected to VCCN, positive. Pin 8 is also connected to positive, and pin 7 is connected to positive through a 1K 8th watt resistor. I have 2 and 6 are jumpered together on the circuit board that is underneath the 555 to help prevent short circuits and such. Pin 5 is connected to ground through a 0.1 microfarad capacitor. This is metal film capacitor. Everything else is ceramic disc, and I prefer the ceramic disc capacitors. These are larger, but it's the same thing. It's the code 104 capacitor. Pin 5 is connected to ground through this, and then pin 6 is connected to ground through another 0.1 microfarad capacitor, and that is the body of the 555 timer. Pin 3 out is connected to the gate of the MOSFET. I have a 10K pull-down resistor across the gate and the source. I guess there is a part of the 555 I didn't, or part of the pulse width module I didn't mention. The potentiometer, you've got, if it'll focus, which it's just being terrible about, one diode connected to one side and the other to the other side. These are connected positive to one side and negative to the other, and then they are both connected together to this one line. God, this camera is terrible. There it goes. These are both connected together, jumped to pin 7. Pin 6 is connected through this jumper here to the center of the potentiometer. That allows for a full pulse width regulation, or duty cycle regulation, I'm sorry. This should be a 3 to 97% duty cycle at approximately 144 Hertz. This in itself is fully functional. This is pin 3 is your square wave out from the 555. That's your output. It can only do 200 milliamps. So we will connect my ground to the source, like so, drain, and then positive. This is output. This is what will plug into the fan. That is it. I have positive in and ground that will connect to the LiPo, and this entire circuit will be functional. We are going to test it first with the voltmeter. We're going to plug it into the LiPo. Just a quick note, almost every schematic of the pulse width module I've seen specifically for box mods uses the firing switch in line on the output of the 555 timer, and then a dip switch to turn the 555 timer on and off. That's good in theory, but realistically, you only need the fire switch. If the fire switch isn't depressed, nothing is on. I understand a lot of people want a master switch. If you want a master switch, run it in line with the fire switch on power in, and then you know that this isn't running idle, pulling 200 milliamps off your batteries all the time. Okay, had to go take care of something in the house. So, we're back. Everything is here. We are going to test voltage output. This is not going to be exact voltage. It's not going to be accurate. This is running pulses of DC voltage. This is going to give me what it thinks it is getting for voltage. Even a good RMS voltmeter is not going to give you actual output voltage. An analog meter, in my experience, will give a better reading. A high quality analog meter like a Simpson, like an expensive meter. But this is going to give me a fairly close estimate. This will at least show that it's working and show that I didn't screw something up showing you guys. So we're just going to plug these in. This is positive and negative. We'll plug the battery in. And we're hot. Okay. Right away, I can see something is not connected correctly. What is not connected correctly? Now we get to troubleshoot on camera. That is why a breadboard is so wonderful. Okay. First things first, we're going to make sure nothing is shorted out. And that everything has good contact. It looks like it is. I'm not seeing anything that is screaming I screwed up. Doesn't mean a whole lot though, does it? Let's plug this back in. And we're going to connect, let's just pull this out of the way for a minute, directly to ground and output. Now I'm only getting 158. As I turn up the resistor, the voltage increases, 11.04 volts. That is directly out of the 555 timer. You can see that the 555 timer regulates down to 158 millivolts, 0.158 volts, all the way up to, according to my meter, 11.04 volts. Okay, now we're going to connect to positive and MOSFET drain. And I guess we'll find out if I pop the MOSFET somehow. By God, it looks like I screwed the MOSFET up somehow. It's definitely in my MOSFET wiring then. We'll just pull that crap out. Don't do this while it's got power, because you can very easily fry something. I'm a little frustrated at the moment, because I just tested this for you guys right before I started filming. Okay, in a second, I'll show you guys the inside of this. This is not pulse width modulated. This is unregulated 3 series, but it's kicking ass pretty good. What have I done to it? I didn't do anything to piss you off, did I, MOSFET? Okay. The MOSFET should be turning on anyways. So what we are going to do... There's no point. I may have blown the MOSFET up, guys. I may have shorted it out and fried it. It's been sitting out here on the table for a minute. It would definitely be the first one I had fried without blowing up. I don't know if that's anything to be proud of or not. Okay. I have definitely screwed something up. Okay, regardless. I can actually hook this up without the MOSFET. We're just going to rip that crap out of there, along with the resistor, because we know this part works. So rather than the big fan, I apologize, we're going to use this cute little bad boy. If the camera knows how to focus. Okay, 0.13 amps at 12 volts. And this will connect to positive because the power coming out of pin 3 is positive, and then to the ground rail. And we're going to turn this all the way down, and you may actually be able to hear the fan hum. Huh. It helps if I hook the freaking ground up to the actual ground pin. If you guys are wondering, this might be why I haven't made a video of this sooner. Focus. Okay. And it's working quite well, actually. Let's just set that down here. Actually, that's a perfect... Look at that. I just figured out I can use that to probe to test voltage. Woo! We'll hook up positive and negative here. Oh, the voltmeter made it sag. It's actually pulling even more. It's sagging to 10.7 volts with the voltmeter connected. Let's see how low that the meter will read this thing while it still spins. Okay, I'm at 1.425 volts and the fan is still spinning. 1.2. That's it. But it functions. Watch this. It actually runs better without the voltmeter attached. Okay, so that is the basics of the pulse width module. It is as simple as it gets. It helps if you don't fry the MOSFET in the process. Makes me curious. I really wanted to show this thing actually running with some decent power behind it. And it really bothers me that it won't. So we're going to try this. one more time. Okay, I got negative in. Got my source hooked up to ground. Got my positive power wire. And my drain. And we're not even going to jack with the voltmeter. We're just going to hook it right up to the fan and see what happens here. Nothing. Damn. Oh. Oh, it's just a loose Dean's connector. Huh. After all that. Okay. I'm sure you guys can hear that hum. Okay, a few things about this pulse width module circuit. One, this is a super simple circuit. As far as your potentiometer, you can go anywhere from a 10K to a 100K. This is a 100K. If I put a 10K in, it would do exactly the same thing. It would just run a lower frequency. As I said earlier, 0.1 microfarad capacitors with a 100K potentiometer will produce 144 hertz. A smaller capacitor that connects 6 to ground will actually increase the frequency. This is actually a 100, which there's no way in hell the camera's going to pick that up. If it does, I'll be shocked. Of course not. Okay, this is not a 104. This is not a 0.1 microfarad capacitor. 5 to ground does need to be a 0.1. I've seen a lot of them that say a 0.01. It's not very picky. All this one capacitor does that connects 6 to ground is adjust your frequency. You cannot go lower than a 10K potentiometer. It will not operate properly. That is all there is to this. Obviously you have to use a freaking power connector that works. Otherwise, that's it. It's done. If I were to put this on a circuit board like this, hook up my wires and hook up a switch and a MOSFET and actually hook it into a 510, it would function flawlessly. It would work just like it's supposed to. You would have effectively full voltage regulation. The only reason I'm using the 3034 MOSFET in this here is because it fits. I don't know how well you guys will be able to see this. Where's my other light? I'll show you the best flashlight I've ever made. It is a brass Nemesis with a cheap, I think that's actually a CLT atomizer with two 5mm LEDs, and one of them is actually broken loose of ground. You just give it an 18650, and I think one of them has broken loose of ground, so it probably, oh, look at that. Boom. Okay, now let's show you the guts of this box. Do you see that MOSFET? It's kind of wired in there pretty heavy. Here's a 3034 for comparison. Maybe. 3034. And that thing. That is an IXFK 180N07. It is rated at 720 amps on a pulse width, running on a PWM. It is a monster. I believe it's a TO264 package, and they're almost $10 a piece. This is a straight unregulated 3 series. This is my 5,000 milliamp hour LiPo. I had to take the hard case off to fit it inside the housing. It's a Radio Shack project box. My favorite enclosures because they're cheap and easy, and if you screw them up, you just buy another one. And here we have my Maximus. This is not the 510 version. This is mounted directly into the case. And some nasty yellow cotton with 22 gauge nichrome 80, 12 wraps on a quarter inch bit. Let's see if we can adjust the camera so you can see me. Of course, it's not going to stay hooked up to the charger. Hi. Okay. Some bitch. That is nothing. Well, you might not get to see it. Okay, forget this crap. I'm just going to assume that you guys can see me extremely well, because I have no clue. Get this crap out of the way here. I'm short. Deal with it. Okay. Let me try something. Okay, I think that'll work for a second. We're going to try to blow some clouds and see if it'll come out. Vape on, guys.